So we're going to begin talking about some extensions to the course that you've been doing, Foundations 11, and particularly about inequalities and linear equations. So what you've done so far takes you to a certain point. This is just really to add to what we've already done. There's a couple of different topics we're going to talk about, and depending on your ability to have done the essential stuff. So when we're talking about solving linear equations, you have an idea of how to do this by following steps like trying to isolate x, get it to one side, do reverse order of operations, those kind of things. The only difference here is that these equations, if you look at them, are slightly more complicated. So there's a couple of fractions involved. So you would have done something, if we just take an example, you would have done something like this, 3x plus 5 equals 12, for example. You would be able to solve that. That's the hope at this point. And we're going to follow very similar steps. We would try to get the x by itself. So the first thing you do is take the 5 over and get 3x is equal to 7, and then you divide by 3. The difference here is you don't have division in this equation. It's just multiplication, addition, and subtraction. With these equations, they involve division. They involve something where x is divided by something or y is divided by something. And so to deal with that, all we're going to do is whatever the number is down here, whatever the denominator is, we're just going to multiply the entire equation by that because that's the reverse operation of multiplication, it's division. So x over 3, we're going to multiply that by 3, so we're just going to get x times 3 divided by 3 if you want to write out the steps, and then 25 times 3. We'll do that over here. So what we end up with is x, because this 3 and that 3 cancel, and 25 times 3 is 75. So that's our answer. X is equal to 75. Very similarly here, the only difference is there's a minus 3 in here. So we're going to do the same thing. We're going to look at our denominator. Our denominator is 10. So we're going to multiply by 10. If there were more denominators, if there was a 3 over 7 and a 12 over 5 or something like that, you would multiply by the greatest common factor. You would multiply it out so that you got all the denominators to be the same. All right? Or the least common multiple, I guess it is not the greatest common factor. You try to find the smallest multiple of each of them. So if you have, for example, if you had a 2 here, it would still be 10. If this was a 4, now it would be 20. That you would multiply by. I don't have that here. I only have the one denominator, so that's all I'm going to do. But if there is more than one, we multiply by the common denominator of the 3 terms or 4 terms that are there. So we're going to multiply by 10 here because it's the only denominator. Y over 10 times 10. You can write this out as 10y over 10 if you wish to. You don't have to. You can just write it as y. 3 times 10 is 30, and 12 times 10 is 120. So then the 10s cancel, and I get y minus 30 is equal to 120. And then I simply go and add 30. So I'm going to add 30 to each side to try to get y by itself. You may have been taught to do it this way. You would have done that in grade 9, or you might be sort of one of those arrow people, which likes to bring the arrows and just indicate I'm bringing that to the other side and changing the sign. Either way, you end up adding 30 to 120 and getting 150. So your answer is 150. All right? And you can always check your answer. So if we take 150 and we divide it by 10, we get 15. If we plug it back in here, if you just want to write that down, you can always check your answer with these things whenever you're solving an equation by just plugging it back in. So 150 divided by 10 minus 3, that gives me 15 minus 3, and that gives me 12, which is supposed to, so I can say, yes, I'm right. And I would encourage you to do that. Every time you do an equation where you solve for x or for y or whatever it is you're solving for, check. The only danger is, of course, that if you check it incorrectly, you might think you're wrong when you're actually right. But generally, you can check and get the right answer again and make sure that you're right. And so I'd encourage you to do that. So here's another one. Same premise. There's only one denominator. It's 12. So I'm going to take and multiply everything by 12. 12 times 4 is 48. And here I'm going to skip the step of writing out 12x over 12. I'm just going to write this as x because 12 divided by 12 is 1, so it's just 1x. And then 15 times 12 is 10 times 12 is 120. If you're not sure, I just want to show you this. You can use your calculator, obviously, but just a nice little mental math technique. It's pretty easy to do. 10 times 12 and then 5 times 12 is 60. And if you add them together, you get 180. That's one way to do it mental math-wise, or you can know that 15 times 4 is 60. If you know that, then 60 times 3, that's the other part of the 12, because 12 is 4 times 3, also gives you 180. There's a number of different ways to multiply that out. But we end up with this. The only issue here is that this x is negative. So I'm going to take it, again, if you're an arrow person, you can bring it over, or you can write it like this. You can add x to each side. Either way indicates what we're doing. And the 180 then I'm going to bring over here, or again, you're subtracting 180 from this side. So you're subtracting 180 from over here. So what the result of that is, that I know it looks confusing, but the result of what we're doing is this. We're getting 48 minus 180 is equal to x. And then 48 minus 180 is, again, a little mental math technique. 50 minus 180 is minus 130, so this is minus 132. It's just a quick little way to do it if you're not sure. All right, so we get that. And again, you can check your answer. I'm not going to this time, just because I showed you how to do it just up here, and just for the sake of time, I'm going to continue. But that is how you solve linear equations with denominators. So that is the first part of your extension. If you want to take some time now and look in your booklet and do some work with those, or look in your textbook if you're using a textbook, then you can do that. If you're happy with doing that and you think you're good, then we can move on to these. So the next step is to try to determine the x and y-intercept. And to try to determine the x and y-intercept, you already know the x-intercept is when y is equal to 0. You already know that. And you already know that the y-intercept is when x is equal to 0. Oops. So all we're really adding to this is a little bit of a more complicated formula. But it's similar to what we just talked about. So here, this one is, because it has a denominator. This one has brackets, which we'll deal with. And then this one has fractions. So they're all slightly different. And this one has fractions coupled with brackets. So there's a lot of different ways that we can make our mathematical formulas more complicated, and each way is dealt with very similarly, but there are just some techniques we have to use in each one. So this one, what I would suggest, you know how to find the x and y-intercepts if something is in the form ax plus by equals c from your essentials. And what you do, the x-intercept is c divided by a, and the y-intercept is c divided by b. You should know that from dealing with those with your essentials. So it shouldn't be too hard to do this if we can get it into this form. So we're going to try to do that by multiplying, just like we did in the last slide, multiplying everything by the denominator. The denominator is 2, so now I'm going to get x plus y, because that 2 is going to cancel with that 2, and it equals 12. And now I can say my x-intercept is 12.
Okay, now from 215 to 220, you'll transition to your D block, and your D block will be from 220 to 230.
Okay, 12 divided by 1, 12 divided by 1. So we get our x-intercept to be 12, 0, and our y-intercept to be 0 and 12. As we move on, we can run into things like this, where we have fractions going away. We don't have any denominators here, but now we've introduced this little guy here, these brackets. So what we're going to do is we're going to multiply out the brackets first. We're going to go 2 times x and 2 times 3. So we get minus 6 equals y minus 1. And then all we're going to do is we're going to bring the y over here and the 6 over there. So we're going to get 2x minus y is equal to minus 1 plus 6. And that gives me 2x minus y is equal to 5. So that allows me then to go the x-intercept, again, keeping in mind that it's c divided by a. It's that 5 divided by that 2. My x-intercept is 5 divided by 2. So when I write it out as an actual coordinate pair, it's 5 over 2 and 0. And the y-intercept is b, the number in front of the y, which in this case is -1, and the c. So it's 5 divided by -1, and that just gives me a y-intercept of 0 and -5. And when you're writing out intercepts, you always should write them as a coordinate pair. So the x-intercept isn't 5 over 2, it's 5 over 2 and 0, technically. Although it is 5 over 2 in the x. So that's how you deal with a fraction that's just one fraction. That's how you deal with things that are brackets. This one's interesting because it comes back to what I was talking about earlier. There are 3 different denominators here. So the least common multiple of 3, 4, and 2 is 12. So I'm going to multiply this whole equation by 12. All right? So we just have to be careful. But 12 divided by 2 is 6. So I'm going to end up with 6x. 12 divided by 3 is 4. So I'm going to end up with 4y. And then that's going to equal 12 divided by 4 is 3. 3 times 3 is 9. Okay? And then we can go, because we're in that form again, ax plus by equals c, we can say our x-intercept is 9 divided by 6. That reduces to 3 over 2 if you divide them both by 3. So my x-intercept is 3 over 2 and 0. My y-intercept is 9 over 4. That doesn't reduce, so I just say it's 0 and 9 over 4. And that's how we deal with those fractions. Now this one is interesting because it has both fractions and brackets. So I like to deal with the fractions first because they're out front of the bracket. So I'm going to multiply this by the least common multiple again of 2 and 5, and that is 10. So I'm going to multiply by 10 and get 10 divided by 2. Sorry, I won't write that out. I said it and started to write it. We're going to go 10 divided by 2. That's 5. We're going to leave the brackets alone. We haven't done anything with them. And then 10 divided by 5 is 2. So we're going to have 2 onto y plus 1. And that equals 12 times 10, and that's 120. So we get 5x minus 15. We multiply the 5 by x and the 5 by 3. And then we're going to have 2y and 2. So we're going to go plus 2y plus 2, and that is equal to 120. And then I'm going to just bring my 15 over and my 2 over. So I'm going to have 5x plus 2y is equal to 120, and then plus 15, and then minus 2. So 5x plus 2y is equal to 133. And if you look at that, it's in our form again, ax plus by equals c. And so therefore our x-intercept is 133 divided by 5. That's not reducible, so we'll just leave it alone. And our y-intercept is 0 and 133 divided by 2, which also does not reduce, so we'll just leave it as a fraction. So that is how you solve for the x and y-intercepts of things that are slightly more complicated. You're going to be asked to do that on your extensions test.